Right. So can you hear the
Hey,
voice of
Figures,
the
can you
video?
come here?
Yes, sir, can you?
All right, nice. Right. So this video is actually published like very recently, like 2 months ago. And I just want to share this video in the beginning because to give you like a brief idea on how the future of robotics is going to look like. Because I'm pretty sure like all of you might have like heard about robots, maybe in films, in movies, maybe in cartoons, maybe you might have actually seen real life robots. But I mean, in films, like we see really advanced robots doing like unimaginable things. But in the real life, robot robots have been so naive, so naive. Like they didn't have that much capabilities, to be honest. Like most of the robots were either teleoperated, they were remote controlled, or like maybe they were just hard coded to do a certain task. All the robots that we have seen so far, most of the robots, they didn't have like real intelligence. I mean, they had a set of hardware, they could move their arms or legs, maybe they had wheels, whatever, but they didn't have that real intelligence to really understand the world or the surroundings around the robot or the environment and adapt to that given environment. That was actually not there until like last 2-3 months. So during this like last year, the field of robotics has evolved so much. I mean, if you are really keen on if you're really keen into like global news, maybe current affairs, you might have seen like companies like Nvidia, Disney, even Disney Research, and they have invested a lot into like developing this next gen artificial intelligence to power robots. So that has been the trend so far. And I just want to like share this video that's from a company called Figure. So they came up with a system called Helix. That's like a very brand new intelligence for robots. So they have this robot platform that they're building, but the robot is not the amazing thing here, the impressive thing here. The impressive thing is the intelligence or simply say the software that runs the robot. So, I mean, that software or maybe the AI, it's not something like hard coded or pre-trained. The robot is able to adapt itself to a given environment, to a given situation. So that's what they really unlocked, like with their invention. So I mean, this video or this demonstration actually took by like it took the storm. Like all the researchers and engineers in this field, they were really amazed by this video because that has something like this has never happened before. Like even we have seen these things in movies, like it came to the real world right like 2 months ago. Let's go to the video.
Okay, I'd like to try something new. Even though this is the very first time that you've ever seen these items, I'd like you to use your new Helix AI and try to reason through where you think they belong in the scene, and then work together to put them away. Does that sound good?
So these two robots are interacting with each other. And these tasks, I mean, the things they do here, they're not like pre-programmed. They look at the objects in front of them and then they adapt themselves to perform that task. And the motion and the everything they do looks so human. Like these actions are exactly what a human would do in this situation, but a bit slower than a human would usually do. Yep. So I mean that video was like, I mean these robots didn't do like very impressive stuff. But the thing is, like, the little things they do, like picking an object, picking that can, or picking that packet of milk, even though that's a really small task, like that has never happened before. Like maybe like 2 years ago, like if someone asked an engineer who's working with these kind of humanoid robots, they might be like really like confused, like can we really do that? Even though that's a really simple task, it was really impossible for us to like let a robot like actually understand the complex shapes of like an object which has never seen before and adapt into it and actually grab it. So like all of these things came into existence like advent of having general purpose robots. Because before that, like like robots have been always in the scene in industries, in like at home. Like like people have been using robots for many use cases, but all those robots were mostly application specific. Like, I mean, if you have heard about a robot called Roomba, it's like a small robot. Like most of the like American European households, like it like had a Roomba robot to clean their floors in office spaces mostly. So I mean, robots have been there for quite a long time, but all these robots were application specific, and there were robots in like vehicle assembly lines like for a long time now. But all those were, I mean, those robots were just manufactured to do that specific task. But the concept or the idea of having general purpose robots is quite new. A robot that can do almost any task. Like we haven't like programmed or coded that robot or build the mechanical structure of the robot to not only do one task, but to do any given task. It's like having these general purpose PCs. Like we can run any application on them. Like that, we have general purpose robots, and that comes into play with the advent of AI. So now we have very like state of the art artificial intelligence systems. So we can incorporate them with robots, and then you can get general purpose robots. So by having such robots, we can have a generalization of tasks. That means we can generalize all the actions, not just specifically program a robot to do a certain task. And also with this demonstration they did, the Figma company did, they came up with this concept called adaptive manipulation. That means the robot might be presented with a ball, maybe presented with a cap, maybe another like a soft toy, maybe a ball, maybe a glass, whatever the object presented to him, it can adapt its like grasp. So if we take our grasp, like as humans, we can like grasp any type of object, maybe a ball, maybe a box. Like depending on object, we can like adjust our fingers and adjust our orientation, the hand position, and we can grasp it. But for a robot to do it, that's like a very complex task. But with their system, they could come up with a solution for that. And next, this concept called zero shot multi-robot coordination. That means there are two robots. That means there are two robots. Sorry. That means there are two robots who can coordinate with each other and collaboratively do a task. So that's like a whole another level of innovation. To like for that, two robots have to communicate with each other and have a proper understanding between them. So that's the next level thing. And then they came up with like a neural network that can do everything. Like even in our semester projects, like if you are like given a task or if you have a project to do an AI related project, like easiest approach is to have like a different network or a different system to do different like tasks, because that's actually easy for us to train them separately and then maybe combine them at the endpoint and have something working just for the demonstration, right? But I mean, even in the industry, that's been the case actually so far. But that's actually very resource consuming, because to run separate like AI algorithm, like AI or maybe machine learning algorithms or any software and algorithm like separately, like parallelly, that's very costly. But what they did was they create one neural network or one system to do everything, like from like language understanding, vision understanding, and calling like to do certain actions, everything in one neural network. And that's what we call as vision language action model. And I'm pretty sure like all of you have heard about large language models. So large language models are like pretty trending, like they're like a buzzword, because like we have ChatGPT, we have like Gamma, Gemini, Claude. There are a lot of LLM tools that like we have been using as undergraduates as well. But large language models are actually very old. When you are actually getting into this very state of the art concepts, large language like models have been like long gone. They are very old. Right. Then we got to see visual language models. That means like instead of just having text, like just giving text inputs and getting text outputs, then the scientists developed models to have vision understanding. So we can like input a image, and then the model can understand what are the objects in the image, or maybe we can like give a video and the model can understand what's going on there. And the recent the recent innovation they came up, it's called vision language action. Now this model not just only understand the text or the visual with the visual like context around the robot. Now he can actually map those sensing or the sensory experience to an action. As an example, if the robot sees a door in front of him, now the robot can think by himself and like go through that door. So that's where the robot is actually leading into. And that's where the like current trend of robotics actually in. So visual language action model is like the latest trend in robotics, and like people are researching into like how they can optimize it and how can they build useful applications out of it. And actually where this is going to lead. So the end goal, which might, I don't know like when will we achieve this, but looking at the pace everything is going on, like maybe probably in 2-3 years we'll be able to have this. So the end goal of having such a like sophisticated system is to have a world model for the robot. So what I mean by world model is when you have like it's just very human. Like as humans, we don't have to put effort into sense what is around us. We can see, we can hear, we can sense, we can feel, we can taste, we can smell. Like everything comes in as sensors sensing to our brain, and our brain can process everything and have a good representation about our surrounding. That representation can be physical, it can be emotional, any type of thing. So the world model is something that is as sophisticated as that. So our current AI is mostly into like pattern matching. Like we have two objects, and then the current AI tries to match the like find the similarities or differences between them. That's where we are right now. But with this like with the new inventions, they're trying to reach this world model level where that AI can actually understand, like actually comprehend the world or the surroundings. So that this is like a pretty impressive thing. Like even like I can't even like understand like how cool that would be to have a robot with a world model, like with a world understanding. So I just want to show you like where the robotics is leading into and what the future looks like. But obviously, like as newbies, we can't really start there because that is really out of our league. Like we cannot really start from there. So we have to start from the very beginning. So that I want to share with you as well. So like all those things like autonomy and like all this like everything running on AI, everything is cool. But do we actually need that all the time? That's another question, right? So even though I said like future of robotics is leading to a world model where AI can understand the world, but that's not something we might need every time. Because if you look at the autonomy levels of robots, there are four main types of autonomies. And we have teleoperation. That means we can control a robot by remote control. And then we have the human in the loop, which means like robot has some sort of autonomous capabilities like obstacle avoidance and so and so. But the human is the one who gives all the commands, like go to that place, like turn left, turn right, like all the commands are given by a human. That means human is inside that system to control the robot, but the robot can like do some sort of tasks. And then you have shared control or supervisory control. That means, I mean, you actually might know these shared control applications. So you can mostly see these type of things in a Tesla, like a self-driving car, where the robot can or the car can actually drive by itself. But if the driver wants, he can get the control of the car as well. That's meant by shared control. And then we have autonomous systems. So like especially in these space missions, these rovers and all are like driven autonomous because it's like when you consider the distance between the Earth and the place where these robots are operated, there's a very big distance. So it's actually not practical for a human to teleoperate it because there will be like a huge gap, huge lag between the communication links. So if you take teleoperation, like why we might need teleoperation to control robots, especially in military applications, it's actually forbidden to use autonomous systems, especially if the robots are armed. So if the robots are armed, I mean, it's legally impossible for a robot to operate autonomously. So that's why teleoperation is still in case. And especially like if you look at like surgical robots or clinical robots, again, teleoperation is a must to have. So even though I said future is going to be like AI based, like still these four are there as well. So there are different applications of like different autonomy levels for robots. Yeah. So, and I just want to show you some of the very cool
But if you're not a nice to the character, it can
like
get really
robotics
angry.
applications that we got to see very recently, just to
So
like
you're in
inspire
an
your
interesting
curiosity
audience, so it can actually get into the
to make
audience.
interested in this field. So this robot, now this robot is actually called Blue. I mean, this was first published by or demonstrated by Disney.
And because it's a
So we all know
fantastic
Disney is
audience
famous
today,
for
she's very
cartoons and
happy
all, but
to
they're
see
actually
this.
working on robots as well. So they have this lab called Disney Research
Right?
Studios. So they
Thanks so
are
much.
working on robots. So when it comes to robots, we always the thing that comes into mind every time is robots are always like crazy looking. They look very weird and all. But if you look at this robot, it's like very cute. It has a very cute personality, like just very playful. Like it's more solely for entertainment purposes because obviously it's made by Disney. So the cool thing about this robot is it's not, I mean, in this video specifically, that robot is actually remote control. But like maybe 3 months ago, NVIDIA actually got access to this robot and they like built a system for this robot to run autonomously, and they did a demonstration in their conference as well. So now this robot is actually autonomous. It has his own personality. He can just interact with people and can like make these like very weird looking sounds, and it actually looks like a pet, like a lively pet. And then we have this quadruped robots or robot dogs. Yeah, so these videos were actually taken by our CEO Deepana, who's doing his master's in robotics and autonomy, or like robotics and autonomous systems in ETH Zurich. So these videos were taken from the Robotics Week in Switzerland. So all these three companies, Boston Dynamics, that I'm pretty sure you might have heard before, and Anibotics and Swissmile, they are like the three like leading robotics manufacturers, especially specializing in quadrupeds mostly. And Boston Dynamics, they're also working on humanoids as well, if you have seen the videos of them. So they're like very leading companies. So they are like building these quadruped robots, and especially they are for like inspection tasks like surveillance. And there are other use cases as well that we'll be like talking later as well. And then we have these like robots deployed in different fields. So you have this robot deployed in a surgical application, and then like for doing surgeries and all. And then we have this smart wheelchair, and we have these drone systems. Like, I mean, some of these projects I don't think that they haven't even released to the market as well. They are like still in the research phase. Um, and then robotics are being used in smart mobility.
And things like that.
So just like a
there you can build
uh,
complex missions.
like
Okay,
self-driving
drive
car,
to this storage,
they can
get a
run
container,
autonomously and help maybe
get
disabled
a
persons
trailer,
to get
drive it
from one
there,
place to
leave
another
it
place.
there, then go charging. So it's, yeah, like we have multiple like things to put together to missions. Yes.
And then soft robotics is another very interesting and very like upcoming field inside robotics. So when you talk about robots, like the initial idea that comes to our mind is robots are made out of steel or rigid materials. Likewise, so there are nuts and bolts and everything. But in soft robotics, the researchers or engineers try to build robots out of soft materials like silicon, cloth or textiles, like fiber, like very lightweight and flexible materials. The reason is like by creating those limbs and like joints and everything using soft materials, they become very like nature-like. Like if you look at nature, like our hands or maybe animals, they are actually built out of uh, like very soft materials. Like even if you take like fingers and all, like there are blood veins and all. So in these robots, they're also powered by pneumatics or either by hydraulics. So that's like very similar to how the nature works actually. So soft robotics is another very interesting field. So maybe you can look into like maybe explore about these things later. And then this is another very interesting competition where like I mean, you all know about drones, right? So there's a competition between a robotic drone and a drone operated by human. And obviously the robotic drone or the drone equipped with an AI is going to win the match. So that shows us like how advanced the today's AI are. So these are like fast racing drones. So you can see like in a very dynamic environment, this AI can handle like different obstacles and let the drone go through these obstacles and like outperform a human basically. And then the interesting thing is now we have seen a lot of cool stuff happening in Sri Lanka, but in the world, but what about Sri Lanka? Like, do we have such things? Unfortunately, like in Sri Lanka, robotics is still not a very interesting topic to talk about because we have like actually a lot more things to do beforehand. But we thought like, what if we can bring such cool stuff into Sri Lanka, and if we can build these robotic systems inside our country, that would be like really cool. So that's what we actually want to do. We want to place RoboticGen as the pioneers in robotics and AI in Sri Lanka. So we're actually working on several robotics projects and especially in some AI projects as well. So this just one video of like recent development that we are working on. So this robot is called RoboDog, and it's based on a robotic manufacturer called Unitree. And then we are working on our own hardware and software upgrades for the robot to deliver on several applications that we're working on. Yep. You can keep in touch with our social media. We have RoboticGen in YouTube. We have a Facebook page, LinkedIn, and all the social media. So you can keep in touch with us to get to know about the recent developments with our robotics projects and AI projects. And also we have openings for undergraduates and graduates to get into our team to actually get in touch with cutting edge technologies. Right. So as I said earlier, there are different types of robots deployed in different applications. And there are if you look at the types, so we have underwater robots, robots that look like submarines, and we have ground robots. So ground robots can be either legged or wheeled. So when it comes to legged robots, we have in this here you can see a robot that looks like a spider, and then we have robots that look like a dog, and then you have wheeled robots, and then you have aerial robots, commonly called as drones, and we have robot manipulators or robotic arms, especially used in vehicle assembly lines and industrial factories. And we have service robots. It would be cool to have a robot that can make a pizza, right? So, and then we have the Roomba. So that robot actually I mentioned earlier, Roomba robot that can clean your floor. And then you have humanoids or robot that looks like humans. We have Atlas. We have Diazen. It's actually a Sri Lankan robot made by a company called Arimac. It was quite popular back then in 2017, 2018. If you got to see the news. And then you have cobots. Cobots means collaborative bots in short terms. That means robots that can work collaboratively with humans. So likewise, there are several types of robots. So based on the application, we might have to build or select a robot that might best suit for our use case. So whatever robot that we have, it can be any type of robot that I mentioned earlier. All these robots are based on a simple principle. The principle is sense, plan, act. So if you take a robot, they have to sense their environment. So for that, they have a set of sensors. They have cameras, they have distance sensors, they have LiDAR sensors. If you're aware of LiDAR sensors, you can see them on top of self-driving cars, these rotating sensors. And then they have a brain computing unit, or basically a computer inside them for planning stuff. So they use planning or processing to find out the optimum path to go, or to avoid obstacles, to do navigation, to do image processing and all that. So they plan as a second step. And finally, they act it out. So to act it out, they have components called actuators. So they might be motors, servo motors, maybe lights, any kind of thing that can produce an output. So that's the basic framework of a robot. There should be sensors, there should be a computing unit to plan, and there should be actuators to act. So when these three things comes together, we have a robot. So I mean, now it's actually cool to have robots, but there should be some kind of laws for the builders of robots to govern it. Otherwise, it will lead into disasters, because I mean, as we have seen in movies like Transformers, robot might lead into the end of the world as well. Who knows? But there's certain laws of robots, but they're not actually laws written in a rule book or something like that. These laws are actually introduced by a sci-fi author called Isaac Asimov. So if you have heard, if you are a huge fan of science fiction, then you might have surely heard about Isaac Asimov. So a very long time ago, even this advent of electronics and all these very technological stuff, he envisioned a world with robots. That's actually really crazy to think right now. Like like maybe 50, 60 years ago, he envisioned a world with robots where he thought like how robot could coexist with humans peacefully. So he came up with three laws. That means a robot may not injure a human being or through inaction allow a human being to come to harm. That's simple, right? And the second rule is a robot must not must obey the orders given by a human controller, except where such orders would conflict with the first law. That means if a human orders the robot to harm another human or another animal, like robot should not do that. Otherwise, robot should obey all the orders given by human. And then the third rule is a robot must protect his own existence as long as such protection does not conflict with the first or second laws. So robot can protect his own existence, but if that means it's going to threaten the humans or other animals, there's no option for the robot other than like destroying himself. So those are the three laws that were that were introduced by Isaac Asimov. So even though he was a science fiction author, actually engineers and scientists working with robots actually seem to pretty interested in the laws introduced by him, and they're like a fundamental thing we can see even in theory books as well when it comes to robotics. So then it comes to the fact that like I talked a lot about robots and different stuff, different types of robots that we can see in the world. And why I'm really actually interested in robotics, why I love robotics, love robots. So there are several reasons, and I think like if this is the first time you get to like listen about robots, I'm pretty sure like if you get into this field, these will be the similar reasons that you get in love with this field. So the first reason I got in love with robots is because robotics is multidisciplinary. That means I get to work with different fields and get exposure into different fields like computer science, electronics, AI, and all that. And that means getting into robotics help me to find my passion, because I got to do like different stuff. And then finally I found out like what are my favorite stuff to do. And then to build robot, you should have a team, because building a robot individually is almost impossible because robots are expensive, and robots again, you need to have different set of skills to build a robot. That means you should have a team with different skills that would complement with each other. And then obviously, if you want to build a robot, you should solve a real world problem. Like otherwise, there's no point of building a robot if just for just to look cool. Like because you're spending a lot of money to build a robot, that means you should solve a real world problem. So that's another interesting thing to do. And but that being said, the actual reason I love robots is I get to work with something tangible. Because as a person, for me, I actually hate to sit in front of a laptop and code all day night. I want to like touch some wires and like work with some gadgets and use some tools and actually get into like do something with my hands and all. And actually I have to code as well sometimes. So robotics like allow me to like do all those things and like be very active and engaging with the work I do. So those are the reasons I fell in love with robotics. So I hope this will be the same case for you as well. So why robotics is multidisciplinary? That's another thing, right? So as I mentioned earlier, so if you want to build a robot, you should have a team who are capable of handling these several set of fields. So first, you need to be like very well with electronics basically. That means if you take a robot like this antibiotics robot dog, so all these robots are equipped with a computer, or the technical term saying single board computers like Raspberry Pis, Jetson boards, and so on. Like there are more sophisticated ones in such a robot. And or at the same time, there are batteries. So there might be a method to charge those batteries. And there are electrical systems, there are power systems. So to handle all those things, you need to have a good electronic background. And obviously to give commands to a robot, you need to have a good background in coding. Especially in robotics, there's this middleware called ROS. ROS stands for Robot Operating Systems. Yep. So I mean, we need to be very well with programming. Like we can either use C, or sometimes we'll be using Python as well, especially when we are working with like computer vision or things like that. So those are the two most popular languages we use in robotics, C and Python. And then we have to be very familiar with ROS, which is a middleware. And then when it comes to robots, obviously there will be a mechanical structure, like to have all these legs, to have a chassis, to have a body for the robot. That's a mechanical structure. So we'll be able to like design our own robots, our chassis for our own robots, and to test them and to assemble them. So we should have a good understanding about mechanical systems. And also there's another separate stream called control systems, to like stabilize those robots and to control them and to like actually let them do what is required. And then there's another separate stream with AI and ML. So I mean, just having a robot is not enough. So robot should do something very useful. So we might be having cameras, we might be having like sensors, and we need to collect information from those sensors and process them inside and do like very useful tasks like autonomous navigation, and using these sensors to like identify objects, track objects, maybe get some useful insights and all. So those are the fields that you might have to like really like learn if you want to be an expert in robotics, but it's actually not something you can do overnight. You have to work hard, and that's actually something that I want to do as well, because I'm not even very much like well learned in this field. So I have a lot to learn as well still, and that's something I invite you to start doing. Maybe start from today. So now the actual question, maybe the reason that most of you joined for the session today is, can we actually make such robots? I mean, looking at all those slides and everything, it looks so difficult, right? Like we have to learn electrical, we have to learn mechanical, computer science, AI and ML. It looks so overwhelming. So can we actually make robots? That might be the question that comes into your mind right now. So the answer is actually yes, but surely not a robot like this as our first robot, right? Because it's unimaginable to build our first robot to look like this. But obviously we can start small. So we can build our first robot to be very simple one, can do very like very little trivial tasks. But maybe over time we'll learn a lot. Maybe be able to do and make robots that might be really useful. Maybe we'll be able to sell them as well. So if you want to become an expert of all aspects in building a robot, those are the four like things that you have to keep in mind. So it can be a simple robot, it can be a complex robot. All these robots are going through this four like stages. First, you have to design a robot. So that means you should like, maybe it will start with a pencil sketch. You should like come up with like a high level design, like what are the components gonna be. And then you will move into a like a design software, and then like like design or simulate the robot. And then you have to like find all the components and assemble it. And then for that, you need to be very well with the tools and how to handle those situations and all that. And then after assembling the robot, you have to code it. So that means you have to like be like very well with coding and programming and all that. And after doing all those things, this is the most important part, testing. So you might have designed a good robot, you might have assembled it without any error, you might have coded it really well, but still the robot might fail. And that's what robotics is. You might have spent days and nights building a robot, coding it very well. And when it comes to competition, you bring your robot to the competition day and you switch on the robot and it might not do anything. So that's totally possible with a robot, because just designing and assembling and coding a robot would not do anything. You have to test it and over again. So it might fail in the first attempt, it might fail in the second attempt. You will have to maybe test it out for 40 times to get it work in all the time, like in every situation. So testing is very important in robotics, and you test your patience to the highest limit. So that's something I want to warn you as well, because hardware, because we are working with hardware, and hardware is not something we can rely on any day. It can fail anytime. So my suggestion is, if you want to get started in robotics, competitions are a great place to start. So that's what I did as well, and that's what, like, most of the people I know who are into robotics right now have started as well, have started their journey in robotics as well. So there are a lot of competitions happening around the country and even internationally as well. But before going to the international stage, we have to start in Sri Lanka. So most popular competitions are Sri Lanka Robotics Challenge, organized by University of Moratuwa. And then we have RoboFest, organized by SLIT. And then we have UW Battle Boards. We have Xbotics, organized by University of Ruhuna. And then I think, today I got to know about a flyer called Perabot, another competition organized by University of Peradeniya. I think the registrations are like just open today. So maybe if you are interested, you can form a team and participate for that. So there are several competitions going on, and those are the robots that we built for those competitions over the years. So I mean, these robots look like very small. They look very ugly as well. Like, looking back at the robots that we have made some times ago, they look very ugly now. Like, their wiring is not good. They are not very good. But by building each of these robots, we have learned something, and we have improved so far, improved from these designs. So, I mean, if you look at these robots, they have like these small arms or small grippers to grab objects, and there are wheels, so there should be a method for them to drive. There are sensors, and if you look at this battlebot, so this battlebot has a very heavy chassis made out of aluminium, and there's a water gun to spray water to the opponent. So it doesn't have any like lethal weapons as you see in another battlebots like blades and all. It's just a very simple and fun weapon. We just want it to be fun. So we mounted a water gun on top of that. And then there's this robot that looks like a spider. And then we have Obermaus, so that you will get to know about Obermaus a bit later as well. So even though this Obermaus is very small, it's like the smallest robot in this picture. But Obermaus is very complex, and it almost gives you an introduction to, like, from basics to advanced concepts in robotics. So that I'll show you later in the following slides. So, and over the years, we have won several competitions as well. So we won the we have won the IIT Micromaze, we have won the IIEEE Robo Games, and we won the RoboFest, and we have been to the Technocian World Cup. So those are the stuff we have done, and we have amazed great experiences by participating in those competitions, and we got to know very like important persons, and we got like a lot of insights from them as well. And this is our even these are our smallest and most complex robot that we have built so far. Not so far actually, during our competition days. So you can get an idea about this robot right now.
අපි හැමෝම පසල්ස් වලට ආසයි. ඔයාලා හැමෝම පොඩි කාලේ ඉස්සෙල්ලා දෙන පසල් ගේම් එකක් තමයි හාවට කැරට් කලයට යන්න පාර කියන එක. ඉතින් මේ වගේම රොබොටික්ස් ඉගෙන ගන්න කැමති අයට හරිම ඉන්ටරෙස්ටිං පසල් ගේම් එකක් තියෙනවා. ඒක තමයි මයික්‍රෝ මවුස් රොබොට් පසල් මේස් එක. මේකේ ගෝල් එකක් තමයි රොබෝ මේස් එකේ කෝණ එකක ඉඳලා කෙටිම කාලයකින් රොබෝව බෝල් වල වදින්න නැතුව මේස් එකේ මැදට නැවිගේට් කරන එක. ඔයාලා විශ්වාස කරනවද මේ වගේ රොබොට් කම්පිටිෂන්ස් ලෝකෙ වටේම තියෙනවා කියලා? ඉතින් ඔයාලත් කැමතිද මයික්‍රෝමාස් රොබොට් කෙනෙක් ගැන ඉගෙන ගන්න? හදන්න මේ වගේ කම්පිටිෂන්ස් වලට ජොයින් වෙන්න.
So this robot is called Obermaus, and it's actually a small robotics mouse. So the task of this competition is to build a robot that can navigate in a maze like this and find the center of the maze and go to the center as fast as possible, and that's how we win the competition. So you can see here how we build this robot, and then how we participated in the competition as well.
දැන් මෙච්චර දවස් ගෙවෙමු කියන්නේ ඒකෙන් ගහනවා. ඔය තාත්තා එකනේ.
Right, okay. I'll play that again.
Oh, pangen ha? Pangen ne? Pangen nanti kita. Dah.
Right. So, I mean, like these robots look so small and it packed with like very limited number of sensors. Like we have IR sensors, a motor driver, two motors, and encoders. So if you're not aware of encoders, encoders are used to like count the number of rotations of the motor. So we can use that to like find the distance the robot has moved. And there's a power system, there's a battery, there's a small screen. I mean, even though it's small, like to do a task like that, to go in a maze and find the center of it and find the shortest path so that the robot can like go to the center as quick as possible. To do that, there should be several algorithms to run. So there's like a specific algorithm called flat fill, and we have to implement that, and then we have to optimize the robot speed, we have robot's control and everything. So to do those stuff, we actually need to like integrate very sophisticated like state-of-the-art algorithms with the robot as well. So micromice is like going really crazy in countries like Japan, USA. They have like very big competitions happening annually. Like I mean, the current world record is actually, I guess, somewhere around 4 seconds. The robot can actually, that those robots made in Japan and USA, they can go to the center of the maze, like a 16 by or 16 by 16 maze, in 4 seconds. They're like really crazy speed, crazy fast. So to do something like that, like we have to like code them very well, like integrate like most of the robotics concepts into a very tiny little robot. So this is another robot that we built. So this is a battlebot. So in battlebots, actually, we don't have to really like get into coding or programming like in a micro mouse. Instead, we have to like look into the mechanical structures of the robot more. So we have to build a very heavy duty chassis. We have to have a weapon system. We have to like bind it with a remote control, and that's it. It's like kind of easier to build compared to that small micro mouse, but still they might be very expensive because you have to invest a lot on hardware. So we can look at this competition organized by University of Uvavelas as well. Yep. So to develop to build robots like that, we need to have some set of skills, right? So, I mean, as I mentioned earlier, robotics is multidisciplinary. So as a team, we should possess these skills. So obviously, if you build a robot, if you want to build a robot, there is an electronic system, and to like place that electronic system, we need to design our own printed circuit boards. So if you're not aware of what is a PCB, PCB is actually visible in almost all the electronic components in laptops, in phones. If you like remove the casing, you can see this PCBs inside with all the small electronic components placed. So to design a PCB like that, we need to have a software dedicated for that. So the most professional one, or the software I'm using, is called Altium Designer. But to use that, you need to have a license. So I mean, as undergraduates, we can actually apply for the education license free of charge. You just need to use your university credentials. But otherwise, if you want to use it as a professional, you need to actually pay like a very big amount. And then there's KiCad, which is an open source free one. And there's another one called ECEDA, which is actually online. And it's actually really easy to get in. You do your first PCB design using ECEDA. So that's something I'd recommend. You can start right away. And then to build the chassis or the hardware stuff, or the or the gears, maybe enclosures, or the chassis, you need to design your 3D structures. For that, you need to have your own 3D designing software, and you might have to print your designs as well. So to design or to 3D design, SolidWorks is kind of the most popular software, but unfortunately it is expensive, and you cannot get it for free. And you will have to pay like a very big amount to get the license. But right now, recently, there's this very cool software called Onshape. Actually, I really like it. So Onshape is based on web, actually. So SolidWorks, it's like a very big software. It actually takes a day to actually load it in the computer. Onshape, it's web based. We can just go anywhere and open the web browser, and it will load. And it has all the capabilities of SolidWorks as well. And it's actually free to use. So that's really cool to have. And then we have Fusion 360, another software. Again, you have to pay for that. So Onshape is a good place to start for 3D designing, and you can later move on to 3D printing as well if you have your 3D printer. And then to build a robot, you should be able to program embedded devices. Maybe if you have like if you have like interest in IoT, that might be very useful as well. So in embedded devices, like we have microcontrollers like Arduino, ESP32s, and then we have single board computers, like especially very small computers like Raspberry Pis. We have Jetson boards. So we need to have the small, very limited, like very physically constrained, like resource constrained devices, and we have to program them. So to program them, we should be like very well with programming in C, C++, and in MicroPython languages like this. And then we have robot software. So as an example, we have ROS, so robot operating system, and then with NVIDIA has introduced their own software stacks. And then again, we should be very well with Git and Docker. Those two are like very basic. Even for a software programmer, software developer, software engineer, you should be very well with Git, Docker, and same for the robotics engineer or robotics developer. And then there are a set of simulators. So even if you don't have money to buy all this hardware stuff, we can get started building our first robot in a simulator. So Gazebo is the most like popular and the most robust simulator out there, but unfortunately it only runs on Linux systems, and it kind of there's like a big learning curve if you want to start with Gazebo. But there's this another software called VBots. This like this ladybug icon here. So it's a software called VBots, and it actually supports Windows as well. So you can download it right away, and you can actually code those like very interesting robots I showed you earlier, like robot dogs, spider robots, and like very advanced robots. Even you can load them in the simulator and try to code them. So those are the like the things that you can start learning and get some expertise by actually self-learning. So self-learning is the best way to like acquire the skills in this domain. So if you want to, I mean, like if you want to get into robots, you can have to actually dive into it. You can just learn, you can't learn to swim like on the ground. So you have to actually get into a pool or maybe get into sea and try to actually swim. Like that, if you want to if you want to get into robotics, you have to build your first robot. That's the starting point. So to build your robot, you should have your own microcontroller. Maybe you can buy an Arduino board like Arduino Mega or Arduino Uno, or maybe you can buy your own ESP32. That means you will get Wi-Fi and Bluetooth capabilities as well. So that's another added benefit if you want to purchase an ESP32. And then to program this or code these microcontrollers, you need to have your own programming environment. So either you can use an Arduino IDE, or if you want to go with ESP32, you can code with Python as well, a Python variant called MicroPython, and you can get into Tony. And then you need to build your own circuit boards. For that, you can use ECEDA. It's actually web-based. Pretty easy to learn. There's no learning curve at all. You can like design your first simple PCB circuit board out there in ECEDA and get it printed from China as well for a very little price. And then if you want to build like 3D structures like this gripper here, maybe like a small chassis for your robot, you can do that in Onshape, free of charge, web-based. You don't have to install anything. You can start building your first robot right away. And then still, if you are not like in a mood to buy all those stuff, you can start building your robot in a simulator like VBots. You can download VBots and build your robot in a simulator. So that's the beginner's combo I want to share. So maybe you can take a screenshot. If you want, I can share the slide deck as well. So like, okay, now I built the first robot, and maybe I'll be continuing my journey in robotics. So what is there for us if we are going to robotics? So to be honest, actually, robotics is not a matured industry so far. So most of the stuff in the robotics are still in the research stage. Like it's not like a matured industry as in software or IT, but the prediction is robotics will be the next big thing maybe in 5 to 6 years, because looking at the things that are happening and looking at the pace things are transforming, robotics might be the next big thing. So like if you want to get into robotics, so there are two pathways you can go. You can either go into industry, or you can go to academia. So if you go to academia, you can get your master's or PhD in robotics. And if you want to go to industry, you can be a robotics engineer. And maybe if you want, you can build your own robotics startup as well, like the thing that we did. So if you go to industry, so there are several international companies like RAD, Robotics Assistant Devices, there's ClearPath Robotics. And then in Sri Lanka, there are quite a few robotics companies like Zone 24/7. We have Arimac. And probably RoboticGen might be in the list in the near future. That's our wish as well. And then if you go into academia, the MIT, Carnegie Mellon, ETH Zurich, University of Michigan, and Stanford are the top 5 universities in robotics. And ICRA, IROS are the 2 main conferences related to robotics. So if you actually go into ICRA and IROS, you might be able to see the cutting edge developments in robotics and AI. So, I mean, for this year, these conferences are yet to happen. I guess in May or June or somewhere like that. So if you are interested, you can get in touch with these conferences, and you can see like leading researchers in robotics coming to one place and demonstrating their like best robots and best systems to the world. And then my advice is, if you want to get in with robotics, you have to always start small. Your beginnings will be very humble. You will have like form your like team. You might even fail in your first competition. So that was the same case for this team from Elizabeth Moyer. Like they actually participated in several competitions. Even in SLRC, their robot actually didn't like move an inch when they started the robot in the finals. But later they learned from the experiences. They like figured out their mistakes and they fixed it, and they actually won. Like they were able to win like a major global competition, and then won the best engineering award for their robot designs as well. So that's how you should do as well. So if you want to get into robotics, my advice is you have to form a team, like find like members with different skills. Maybe they don't have skills yet. Maybe they're just passionate. So passion is what drives you to the success. So you have to create a team and devise a master plan and try to acquire the skills I mentioned earlier and register for the next robotics competition right away. You might not be able to win that competition. I mean, that's really like impossible. And if you do like that, that means you are like next level. But try to participate and gain experience from that. And you can look at what are the what are the things other competitors are trying, what are their secrets. You can observe them and then prepare yourself better in the next competitions. So you have SLRC, we have Robo Games, RoboFest, and Exportics, and like a lot more competitions. So those are the main 4 competitions that I wanted to share, but there are a lot more competitions happening around the country. So just participate in those competitions, and then you will like find the passion inside you. So yeah, that's the session I want to like share with you, and I hope you might like all of you got something new today, like got to know something new. And before wrapping up the session, actually I have prepared a small quiz as well. Maybe we can do that. I just want to like tell a bit about RoboticGen. So RoboticGen, we actually started 2 years ago as the academy because we thought like if we want to become future tech leaders, it actually starts at a very young age. So if someone wants to be a world class, so people like they have to start learning at the age of 12 to 18. So that's not something I'm saying. It was mentioned by Bill Gates. So our intention was, how can we create the future of our country? So that's why we came up with our product with the Robotics Academy, where we wanted to create a quality like learning environment for our future generation to come and learn the best technologies out there and then become the future tech leaders. So, and then we came up with another initiative called RoboticGen Labs. It actually launched very recently. And basically our goal is to lead the tech today here in Sri Lanka and maybe in the region as well. So we want to drive the future generation with robotics and AI, and we are doing like research projects. We do like a lot of like things inside our team to like improve the skill level of our team members and so on. So obviously we are growing day by day, and if you are really interested, you can even join our team and you can like join our community for robotics and AI. So there's our YouTube channel, and we have other social media. We are publishing research videos, podcasts, tutorials, and you can actually be interactive with them as well. And if you're really interested, you can even go to our website, roboticgen.co, and there's a career page, and there are several openings as well in our website. So there are obviously options for, in our academy, we have openings for mentors. So for undergraduates, so we actually wanted to create an ecosystem for undergraduates to join us and learn, and at the same time they can earn a part-time income as well. So if you are interested, you can join us as a mentor, and there are openings for our RoboticGen labs as interns for software team. And then we have some openings for operations manager, operations internships, and some marketing and sales internships as well. So if you are into these stuff, you can even go into our channel, our website, and apply with your CV. And yeah, So those are the openings that we have. You can go into the website and apply.
We are heading to the age of technology where innovation and creativity are the foundation to solve the world's biggest problems. Traditional learning methods won't prepare the future generation to thrive in this modern world. So, with many years of research with professors of top universities and engineers of top tech giants, RoboticGen is happy to introduce a novel way of learning for kids in the age of 10 to 18, which we call journey-based education. Here, the students have to follow along a journey with a cute and curious robot called the Obo Junior that goes on a world tour to become a superhero. In this journey, the students get to solve SDG-based challenges every week while learning STEM concepts. So far, more than 35 students and parents love our innovative approach, and our experience is accredited by STEM.org. We are really excited to see how our young innovators would solve the challenges of tomorrow.
Yeah, so that's it. So maybe if all of you are there, we can move into like a small fun quiz session. Yeah, so maybe I can start it now. Okay, let's start the session. So the first question is, what is a movie related to robots? Real Steel, Home Alone, Charlie and the Chocolate Factory, Beauty and the Beast. What's that? So keep in mind that when you answer the questions fast, you get more points. Yeah. So I think maybe only 5 of you answered the quiz, maybe. Oh, no, 16 answered, right? Okay, Real Steel. So that's the correct answer. Okay, let's go to the next question. Since when the word robot was first began to use? Is it 100 years ago, 8 years ago, 50 years ago, or 30 years ago? It's a bit tricky question, so you have to be right. So we have Anushka in the first place. Yeah, so most of you answered 80 years ago, or maybe 50 years ago, but actually it's 100 years ago. So, I mean, actually this word or the term robot came in existence in a drama in this country called Czechoslovakia. So, I mean, 100 years ago, I mean, like we didn't even have electricity back then as humans, but this term robot actually translated into iron slave in Czechoslovakian language. So they had a puppet made out of iron in that drama, so they named that as a robot. So that's how the term came into existence actually. Next question. What humans are good at compared to robots? Is it, am I having problems with that? Doing repetitive tasks, doing labor intensive tasks, doing creative activities, or doing risky tasks? So what humans are good at compared to? Right, we have Anushka at the top, and then you have Senindu at the second place. Yeah, most of you answered it correct. Humans are good at compared to robots actually in creative activities. But looking at the recent developments, you might think like even like the newest ChatGPT models, OpenAI models, they are actually good at creating images and all as well. But still, these images are not very original. So if you look at the recent trend with Ghibli, they are always based on like the things that are being like shared with the internet. Like they are not like developing their own like image styles or painting styles. They are based on some kind of a style developed by some other person. So that's not creativity actually. What is the name of this robot who is considered as the most advanced human shaped robot? But actually this is a kind of a old one, to be honest. So this robot, when it was first introduced like some time ago, Yeah, we got Senatni in the first place now. So most of you actually answered Sophia, but the actual name is Ameka. So Sophia actually looks a bit similar, but this particular robot is called Ameka. So that's kind of another tricky question. So Sophia is actually a robot made in Dubai. So, but that in Sophia, it was mostly the head of the robot. But in America, the whole body is very functional with like arms and legs, everything functioning very well. And the next question is, what is the name of this general purpose foundation model for humanoid robots showcased by NVIDIA in March 2025? So NVIDIA actually demonstrated a new foundation model or an AI for humanoid robots. So what's the name of that one? Yeah, so actually leaderboard got shuffled up. We have Senate at the top now. So the answer is Groot. So actually not Groot, it's GR00T, sounds as Groot. So like the Groot in that Marvel movies. And then, yeah, that's a correct answer. Groot was the foundation model introduced by NVIDIA recently. What programming languages are used for robotics? C, C++, Python, or all of the above? Yeah, correct answer is all of the above because we use C, C++ for low level stuff, and we use Python for like AIML stuff as well. Next question, how do robots know where to go or what to do? They use sensors and cameras to see. They have a magic boom that shows them the way. They can smell pizza from miles away and follow the scent. They are asked their robot friends for directions. So that's kind of like a weird, fun question. All right, what powers most robots? I don't know who made these questions actually. Not me. Those two are like a bit fun questions. Which of the following company is not involved in robotics? APV, Boston Dynamics, Disney, JP Morgan. Yeah, the correct answer is actually JP Morgan. So, I mean, most of you have answered Disney, but actually I showed a robot made by Disney in the session as well. So if you like listen to the session really well, then you might have guessed, you might have actually avoided answering Disney. So that means you haven't really listened well. Yeah, JP Morgan is actually a bank, a financial institution, not a robotics company. ABB, Boston Dynamics are actually robotics companies. Disney, they have a robotics division. What is the this? It's actually you can't answer, I guess. You can. Over mouse, over car, speed turbo, over play. What's the name of the robot that can solve mazes? So all these are developed by RoboticGen, but you are not aware of the other three items. So over mouse is the maze solving robot that I showed you in the video. And Overcar is another mobile robot platform we have developed. And Speed Turbo is a like fast line following robot we have developed for competitions and as a product as well. And then Overplay is a prototyping board we have developed and like selling as well right now. So Obermouse is the correct answer. And then how are robots helping farmers around the world? Is it by baking pies with fresh ingredients or by telling the cows funny stories? By planting and harvesting crops automatically? Or by acting as scarecrows and dancing in the fields? Like how actually robots are helpful for farmers? That's another fun question. All right. So you can end the session. So in the first place, we have got Senethmi, and second place got Ruan. Third place got Anushka. Or Anushka, I don't know what's the name. All right, thank you everyone for participating. Yeah, that's it the session. So if you have any question that you want to ask, you can now use this opportunity to ask them, so we can wrap up the session. I think we are good with the time as well. We are on time. So if you have any questions, you can ask them. You can unmute yourself and ask. Maybe you can put them in the chat box as well. Yep.
Thank you so much, Mr. Odil, for that engaging session. Your knowledge and experience have provided us with valuable insights into robotics. Now we will give you 5 more minutes to fill out the Google form and secure your e-certificates. Also, make sure to submit it in time.
Can you please recommend a good PCB printing place locally? Yeah, so actually there's no such place to print. Like if you want to get like individual pieces, like maybe 2, 3, like 5 PCBs printed, like it will be like more expensive than getting from China as well. Like if only if you are going for like 1,000 pieces, it will be cheaper here in Sri Lanka. But yeah, there are like local places to get it done, but the precision is not that well. Like you might be able to, you will have to like limit your PCB to 2 layers, and then like they can't like print very thin PCB traces as well. So there's actually no place that I can recommend, to be honest, the local place. So I always find it easier to like place an order to JLC PCB and get it printed and delivered. What I do is like maybe when it comes to like semester projects and all, like maybe like several teams can get together and place the order together. That is kind of a way to minimize the shipping costs. Yeah, other than that, you can like maybe try to contact a like this logistics companies operating in China. So you can ship your PCBs to their location in China, their warehouse in China, and they will like deliver it to you for a very fair price. Yeah, that's another way, like a cheaper way to get it done. Like it will take like 2 weeks, around maybe 1 week, 2 weeks to get it delivered, but still it's more like economical, more affordable than getting it delivered with a logistics provider like FedEx or DHL. Yeah, that's the way I recommend. I don't actually recommend local printing services because they are very crappy, to be honest. Any platform to learn PCB design? Yeah, so the way I actually learned PCB design was actually through YouTube. So there are like 2 cool personalities in YouTube. I'll actually share the YouTube channel. Actually forgot the name. James Faranack. James Faranack is like a very leading figure in PCB design in YouTube. Faranack. Sorry, not James, actually Robert Faranack. So I share the YouTube link here. Robert Faranack. Robert Faranack is a good YouTube channel to get started. So if you go to playlist, you can find like several tutorials on building your first PCB. Maybe like since you can access to the education license, you can start using Altium as well. But if you want, you can go to ECEDA. ECEDA is actually pretty easy to build your first PCB, and you can directly send your printing for LC PCB and get it printed. So that's actually really easy to build your first PCB if you want to get it ECD. And actually, ECD is more than enough to do like most of the stuff that we might have to do. So you'll be able to settle up in ECD, but ECD is actually not a very professional tool. So if you want to build a professional PCB, you might have to move into Altium. And then there's yeah, those are the two things I would recommend. So if you want to like do something very quickly without a big learning curve, you can go for ECDA. And ECDA, actually, you don't have to actually look into those videos as well. It's actually pretty self-explanatory. There are some guidance as well, some tutorials in ECD itself, in the tutorial section, in the help section. But if you want to learn about concepts in PCB design, Robot Fanac is a really great source. There are like hundreds of videos for you to learn there. Robot Fanac, and then there's another called Fields Lab, I guess. Yeah, Fields Lab. Fields Lab is another great source for you to get started with robotic PCB design. Can you fully trust interactive routing on ECDA? No, actually, I think you mean about auto routing, right? Is that so? Like, I would never recommend doing auto routing, but if you like, yeah, auto routing, like never do that in any platform. Even if you take the most professional tool like Altium, auto routing is not a good option. Yeah, you have to do routing manually. That's the hardest part in PCB design. So you have to place your components and everything on the PCB, and you have to actually manually route it, because you are the person who actually understand the PCB. The PCB software cannot understand your circuit. So just do some wiring, some routing, but it's not the optimized one. So you have to like spend some time onto the design and actually route it by yourself manually. Like there are several considerations that you have to actually think about when routing, like placements, and then like sometimes they're like the best angles to break the traces and the gaps between the traces, and then sometimes you have to like have the better trace width. Like and the trace width is actually very important. Like depending on the current that flows through your traces, you have to calculate it and find the optimum trace width. So it's actually really there are a lot of things to learn. So auto routing wouldn't do that for you. So you have to do it manually. Yeah. Yeah, auto routing is just it's not a good option in any software. Yeah, like to manually route it, actually you will have to spend a lot of time. It will need some skill as well. You have to improve yourself. That only you can only do it by like doing stuff. You have to create more PCBs and get the experience. That's the only way. The first 2-3 PCBs will feel like a nightmare to route. Yeah. Any more questions? Yeah, seems like we are good to go. So we can wrap up the session. So thank you again for joining and being interactive and listening. So hope you'll be like getting into this field as well. Yep. Good night, everyone.
Thank you so much, Mr. Odil Janandith, for that insightful and inspiring session. Your expertise and experience have certainly added immense value to this event, and we are truly grateful for your time. We would now like to present you with a token of appreciation as a small gesture of appreciation. Though it may be modest, it reflects our sincere gratitude for your contribution to techXplore 1.0 and for sharing your knowledge with us today. Once again, thank you, Mr. Odil Janandith, for being a part of this session.
Thank you again, like for inviting me and give me opportunity to share the experience. Right.
Before we conclude, here is some exciting. We have more amazing sessions lined up for you in the upcoming weeks. You can stay updated through our official WhatsApp groups, so stay tuned and don't miss out these insightful and interesting sessions.
As we come to the end of today's session, I would like to extend our heartfelt gratitude to Mr. Odil Janandith for sharing his expertise, to all our participants for your enthusiasm, and to everyone who contributed to organizing this event. A special thanks goes to our sponsors, Creative Code and RoboticGen, for supporting techXplore 1.0 and helping us to bring these learning opportunities to all. That's all for today. Thank you for joining us, and we look forward to seeing you at our next session. Have a great night.